Okay, chapter 9 is neutralization. We actually already did this in chapter 4, so this should be a refresher for most of us. If not, hopefully you can figure it out pretty quick. So we have, I ask you to calculate a whole bunch of things, and I give you HCl, which is an acid, and I'm mixing it with barium hydroxide. So this is the first problem we've had so far that's an actual chemical reaction. It is acid-base neutralization. Okay, so I have two major species. I have HCl, which is a strong acid, and I have barium hydroxide, which is a strong base. Okay, so actual chemical reaction going on right here. They could present this as a titration. Remember, titration just means the lab technique of them mixing the acid and the base together. Okay? So first thing you have to do is you're taking two different solutions and you're mixing them. Mixing them causes dilution to happen. So you need to dilute them right away before you even react them. So what's dilution? M1V1, M2V2. Okay, so you need to do this for the acid and you need to do this for the base. I'll do it for the acid. You can do it for the base on your own. So molarity of the acid is 0.24. Volume of the acid is 50. The new molarity after they're mixed, we don't know. And the new volume after they're mixed is 100. 50 and 50 is 100. Okay, so you take and you divide both sides by 100. And the molarity of the HCl, let's see, I got it to be 0.120 molar for the HCl. Okay? All right, you do this again. You do 0.2 times 50 for barium hydroxide, and then you divide by 100, and that's the base, and I get the base to come out to be 0.10. Are we at 3 sig figs? Ugh, yeah, okay, molar. Okay, so that's the barium hydroxide. Okay. So diluted, not reacted, just diluted. Okay, so then we need to write out the reaction. Well, HCl, acid, base, barium hydroxide, gives you salt and water. All right, and this is a 2, and this is a 2. Okay. Oops, I don't know why I put equal sign. This is a one-way arrow. This is neutralization. This is not equilibrium. Okay, so there is no equilibrium expression. There's nothing that goes to equilibrium. This is an acid and a base reacting to make salt and water. Okay, now, like equilibrium though, I'm going to set up an ice chart because if you did not already recognize this, this is a limiting reactant problem. I gave you amounts of both reactants, and it's going to be your job to figure out all of this other stuff. Okay, so I'm going to start to solve this like a limiting reactant or like an equilibrium problem, but as a limiting reactant problem. So I'm going to set up an ice chart because remember the ice chart is just an organizational tool. All right. Okay. Here's what I need you to recognize. I'm not going to do the net ionic equation for you. You should be able to do it. It is H plus OH minus makes water. What does that mean? That means barium and chloride are spectator ions. So however much of them you have at the beginning is that same amount you have at the end after the dilution. So your barium ion concentration off the bat is 0.1 molar. Okay? And your chloride ion concentration off the bat is 0.120 molar. They are diluted, but they do not react because they are spectator ions. Remember, the net ionic of any strong acid, strong base reaction is H plus OH minus make water. Okay, so here's my HCl. Now I'm saying HCl, but really I'm meaning H plus. Okay, 0.120. And here's my barium hydroxide, 0.100. Ooh, I didn't balance this. Sorry about that. Okay. So look at both reactants, limiting reactant problem. So you go, okay, 0.1 divided by 1 is 0.1. 0.12 divided by 2 is less than 0.1. That means HCl is my limiting reactant, meaning I'm going to run out of it. So I lose all of it. Right? Okay, well, HCl and BaOH2 react in a 2-to-1 ratio. So the barium hydroxide should be half of what the HCl is. So I'm only going to subtract 0.06 from over here. Okay? So at the end, I have none of this, and I have 0.04 molar barium hydroxide left over. For this one, I'm ignoring my products because I know my salt is there in full tact, okay? And water is a what? Liquid, so who cares? All right? So the next question I'm going to answer right off the bat is the solution acidic, basic, or neutral? Well, if you have base in excess of this reaction, it's basic. If you have base left over, it's basic. So this solution is basic. How much hydrogen ion is left? None. It's my limiting reactant. Is that right? So there's also no HCl. Okay. How much barium hydroxide? I just got 0.04003 sig fig, molar. I did my barium ion right there. Okay. OH minus, be very careful. Is the OH minus 0.04 molar? Are you answering? Okay, it's not. There are double the hydroxide ions in there. So the hydroxide ion concentration is 0.08 molar. Okay, because there's 2 hydroxides every time this splits apart. So 0.04 times 2 is 0.08 molar hydroxide. Okay, so I just found hydroxide. Now I'm going to instantly find POH. Remember, POH is opposite the log of OH. So equals opposite the log of 0.0800 molar. I haven't done that yet, so let me put that in my calculator. I got the POH to be 1.097. Okay, and then it's easy to get the pH now because pH plus POH is 14. So 14 minus this number is 12.903. This is 3 sig figs for pH. Wow, that is really ugly. I'm going to go back. Okay, 12.903. Okay, look, that is a basic pH because we had base left over in there. Just because you mix an acid and a base and they neutralize, they don't always neutralize perfectly. If they don't both run out at the same time, you do not have a perfectly neutral reaction. So in this instance, leftover base gives us a basic pH. Again, this is stuff from chapter 4. One of the biggest things is you need to remember that the spectator ions become diluted, but they don't actually react. We're really paying attention to the hydrogen and hydroxide. And so what I'm going to do is I'm going to show you a way to do this as a net ionic equation as opposed to how we were doing it. Instead of doing this full reaction like this right here, I'm going to do the net ionic reaction and completely ignore the spectator ions because I'm going to know they're these numbers. Okay, and so this is an alternate way to do this problem. Give me a second. Okay, so look, let me go through the net ionic with you. HCl plus BaOH2 makes BaCl2 plus H2O. And so I throw a 2 here and a 2 here. Strong acid, so 2H plus 2Cl minus plus strong base, so we're 100% ionizing. Salt that is soluble, and then water. Oop, I forgot the 2 in front. Okay. Spectator ions, chloride, barium. So 2H plus 2OH minus makes 2H2O. So reduced, that is H plus OH minus makes H2O. Okay, this is really the reaction that's going on. The barium and the chloride are just sitting there minding their own business. Okay, so I'm going to straight up plug H pluses and OH minuses in here. Well, the H plus, right, HCl, was 0.120, right? And then the barium hydroxide after dilution was 0.100. Okay, so 0.120. Now, be careful. The barium hydroxide has double the hydroxide concentration. So really it isn't 0.1 hydroxide, it is really 0.2. We are taking care of doubling the hydroxide at the beginning instead of at the end. All right? So look it. Here we go. I lose all of this. My net ionic is a 1-to-1 ratio. So whatever I lose there, I lose here. None. What is 0.2 minus 0.12? It is 0.08, which is, remember, ignore the water. This is exactly what we got for hydroxide. Okay? This is an alternate route to do it with a net ionic equation. So again, hydroxide 0.08. Same exact ending point. You either account for the hydroxides at the very beginning, okay, or you do it at the end, like I did in the first example. Okay? And then you would just go from here. You have OH, find POH. After POH, find pH. All right, and that is it for neutralization.